Welcome back, everyone, to our fourth episode of Clear Signal, where we talk about some of the challenges and opportunities that millimeter wave imaging radar can bring to the world. I'm your host, David Wu, and this is our Chief of Business, Mazi.
Thanks for joining us for this episode.
Thanks, Mazi.
Yeah, you're welcome. Yeah.
Today, I just wanted to talk about some new and emerging kind of frontier applications for millimeter wave imaging radar, both unlocked by new demand in smart city and smart infrastructure, but also new bands and frequencies that have been unlocked worldwide. Specifically, I wanted to start off by focusing on traffic monitoring. Can you tell me a little bit about what radar is even used for in traffic monitoring?
Historically, radars have been used in traffic monitoring, especially Doppler radars. These radars, for the most part, measure the speed of vehicles. With the emergence of millimeter wave radars, there's a lot that you could do with what we could offer to customers is great angular resolution, great range resolution, and very long range detection. We could detect a vehicle depending on the field of view of the sensor. We could detect a car at all the way to like 600 meters, maybe a truck at close to 800 meters, a pedestrian at 200 to 300 meters, motorcycles at somewhere between 250 to 500 meters. And we could do it with a very fine angular resolution and accuracy. At a couple hundred meters, we won't miss the lane. Like if a car is driving in this lane versus another car in the other lane, we actually maintain really fine angular resolution to identify which lane the car is actually driving through. So that's a really great capability that we have. We could count the number of vehicles through any fictitious line. We could do geofencing. We could find the wrong traffic, detect the wrong traffic. We could also use the same sensor to find static objects. For example, at the junction, people use inductive loops to turn, the traffic lights green or red, and these inductive loops are expensive to install, and sometimes don't even work. Like I ride my motorcycle sometimes, and often it does not detect me when I'm there. So I have to wait once or twice or thrice, and then I'll just sometimes cross the red light because, after 3 times you actually could do it because you can't wait forever there. So the millimeter imaging radar will very easily detect any obstacle, even static ones. Now, it could be a pedestrian walking, could be a motorcycle, a bicycle. It could do classification for you. We could classify many different classes of objects, vehicles, bicycles, motorcycles, scooters, as long as you could train it. You could train it to classify maybe a wheelchair.
The increased sensitivity and the ability for imaging radar to detect not only metallic objects like inductive loops, but also, people, humans, bicycles, things like that, can allow us to have more intelligence in an intersection and improve the safety of veer use.
We could do predictive analysis. So we could predict that a vehicle is coming from 200 meters, and by the time this vehicle arrives at the speed that we could easily measure, there's another maybe vehicle coming at maybe 500 meters or maybe 50 meters. We could analyze which one is going to get faster to the intersection and turn the green light for the faster moving vehicle, the one that is coming first. Or we might detect that, hey, this vehicle is coming so fast, is not going to be able to stop at the intersection. And there's another vehicle, a pedestrian, coming in. So we might keep the light green for the very fast coming vehicle because we're detecting that this vehicle isn't really going to be able to stop, with reasonable distance. So that could be providing extra safety. Also could save a lot of, I would say, time and fuel, because if you don't have to stop and go, you save a lot of fuel.
Right. The more intelligence you have, the more aware you are of the situation at an intersection, the more you can, let's say, improve safety, maybe adjust your dynamic timing so that not only are cars, spending less time stopped at the light, but also risky situations are avoided.
Yeah, absolutely.
So tell me a little bit about how, the installation of an imaging radar would compare against existing solutions like inductive loops.
Oh, it's just so much easier. All you need is a cable, often a PoE or any other type of connection. You don't have to mess with the infrastructure. You don't have to dig in and then install and then make up the pavement. You don't have to do any of that.
Right, because it mounts just on top of the traffic bar.
Exactly, or anything else. As long as there's something standing up there, you could hook it up onto an existing, pole or lamp or traffic light. And in events such as heavy rain or flooding and things that often happen on the ground level, these systems might be damaged. But if you're up there, there's a lot less that could go wrong with your system. So it's very easy to install and it's very scalable.
So Mazi, I'm wondering about how imaging radar compares with maybe other legacy radar technologies like Doppler radar or other frequencies. Can you talk more about that?
Yeah, Doppler radars didn't have the resolution essentially in range or angle, so not very useful. In the US, the band that is open for traffic monitoring is essentially 60 gigahertz, is the ISM band, 56 to 64 gigahertz. This band is a great band. It has a lot of bandwidth, so you could get really fine range resolution. We have a great solution for this frequency band. We call it zPULSE. We could very reliably detect a vehicle up to 200 meters. The rule is that for traffic monitoring, you could only use 60 gigahertz if your radar is a fixed installation. So 76 to 81 gigahertz, unfortunately, does not work in traffic monitoring in the US. But worldwide, that's not the case. In most continents and countries, you could use 76 to 81 gigahertz without any problem. But in the US and Canada, is not the case. Traditionally, people used to use 24 gigahertz. The problem with 24 gigahertz radar is that first, the angular resolution is limited because of the aperture size and the frequency. Yeah, the frequency is lower, so it means for the same angular resolution, you really have to increase your aperture size by a quite big factor. But that's not the biggest problem. The biggest problem is the limit that FCC puts on the EIRP, the emission level. It's pretty low. If it wasn't that low, it would have been a fine, okay frequency, but that's not the case. So because of that very low emission level, the range is limited, and there's not much you could do with it. You can't do much of a MIMO techniques or beamforming because you just don't have the EIRP. That's why people are moving away from 24 gigahertz and trying to use millimeter wave. But traditionally, only 76 was available. But now we have the right frequency that is FCC permissible. And would love to work with customers that are interested in this market.
That's awesome. That's awesome. So I also see that there are other solutions on the market today that use lidar, for example, at intersections. How would lidar compare with radar in this application?
Radar would be significantly a better sensor for this application because it's not only the sensor that matters, is how much data you're generating and the computation that is required to process that data. The beauty of 4D imaging radar is that every point in the point cloud has a Doppler information. And we could easily do static dynamic segmentation. We could turn off all the static points in the environment, which is essentially most of your points, and only focus on the dynamic points. We don't have to do it, but this is done by design. It's a byproduct of the radar. That information, that processing is for free. So we could focus on things that are moving, and the computational complexity of doing it with the radar is orders of magnitude less than doing it with the lidar. So lidar is more expensive than the radar, but that's not the whole story. You have to have even a more expensive processor to process the point cloud coming from the radar, from the lidar. But using the radar, you could do the processing at the edge. So
like inside
the sensor, exactly. So our zPULSE platform, for example, or our zPRIME is very capable. It could do quite a bit of processing at the edge because we have a very powerful FPGA. We could send out an object list, which could include the track number, the number of vehicles, the count, the duration, the speed, the location.
Where they are, the lane, everything.
Exactly.
The type of object as well.
Classification, all of that. Yeah, that could come out as an object list. And that's a very low data rate, in the kilobit per second type of range.
But it's exactly what you need.
That's exactly what you need. You don't need like massive point cloud coming out. And then that's all the cost you pay. You pay, just the sensor cost, like radar. The processor is already included. And the maintenance is very low. The radar is all-weather sensor, works in all lighting condition, all weather condition, dust, fog, rain, snow, smoke. You don't have to clean it. You don't have to maintain it. It's very rugged. It's very temperature resilient. So it's a great sensor overall. Again, lidars are amazing, sensors, but for this specific application, I don't think anything compares to a radar.
Right. I mean, you're saying that our radars can do the processing on the edge. There's fewer components, fewer parts, easier to assemble, and also they're more robust in this type of environment. They're truly like a set and forget sensor. You've got road grime, you've got brake dust, you've got birds nesting, who knows what that might block your optical window, and radar just.
Yeah, imagine you have to maintain these sensors and clean them every once in a while.
Like in your whole city.
It's so difficult. It is so difficult. Okay, if you could do it once a year, maybe it's okay. But if you really have to do it every few weeks, imagine the budget needed to send a crew on every intersection, get up there, clean, come back down. It's just not doable. And in certain places, because of dust and pollution or other reasons, you could bet that the lidar get, the lidar would get really dirty. Blinded. After 2 weeks or 3 weeks, it might just be, pretty useless. You have to really clean the surface. But that's not the case with the radar. Yeah,
we're all about, increasing safety while decreasing operational burden.
And let's say a vehicle produces a lot of smoke for whatever reason. Imagine your intersection fails to work because for whatever reason now you got smoke. And in certain cities, like you have a smoke or water, steam somehow coming out of. I've been to New York and some places in the East Coast. You see the steam somehow comes out from unexpected places, and you just get pretty blinded if you're using a lidar. But that's not the case with the radar.
Yeah, traffic monitoring is a very exciting segment that we're excited to help improve.
Absolutely, yeah. There's an area that we're seeing a lot of interest. And that is, people want to use our 4D imaging radars to count the people inside a vehicle, the number of occupants inside the vehicle. How do we do that? Is it doable? Is this something we could do with the radar?
Yeah, this is one of those things that at first glance on the surface seems like magic because we're not using cameras, we're not peering inside the vehicle with telephoto lenses. But even if people are laying down in a vehicle, if they're sitting crooked, or even if people are obscured, we are able to use radars on the outside of the vehicle, mounted on let's say a toll booth, for example, to kind of scan and detect how many passengers are inside the vehicle. And this application, if you really think about it, unlocks a whole set of possibilities, either at toll booths or at security booths, or at, for example, border crossings. From one country to another, we need to know sometimes the number of people that are inside the vehicle. And we need to do it in a non-invasive way. And at some border crossings in the world, there's just so many, there's just so much volume of traffic that it becomes very difficult for even like a manned toll booth or a border control officer to analyze every car. And so
because he has to move in and out of the cabin or the kiosk like every few tens of seconds, and that's going to be very difficult.
And it's around the clock operation.
It's nearly impossible.
Yeah, so we've developed a new system.
It's a very new system. We call it.
Doesn't even have a name yet.
It doesn't matter. We count people. Right?
People counting.
Yeah, people counting inside the vehicle.
Yeah. So we've developed a new system that uses our zPRIME and zPULSE radar families, combined with a processing unit to capture data from these radars in the toll booth outside the car, and basically reports how many people are inside the car. Yeah. This really has been an interesting technical challenge for our team, because to deal with different sized vehicles, different numbers of people, you might have 2 seats here, 3 seats there, 4 rows, 3 rows, could be a van, could be a cargo truck. I mean, to cover all of these different cases and accurately count the number of people has been a true technological breakthrough that we've developed.
Yeah, without going through some sensitive technical IP, can you touch on how we actually understand the type of vehicle and the wheels and the windows and stuff? So are we able to extract the vehicle shape and features from just the radar point cloud?
Yeah, so this is part of our expertise, is extracting these insights from radar knowledge, radar data. And in our case, we combine data over time from multiple radars as the vehicle is even driving into the toll booth. And you can think of it like we slowly piece together an image of the vehicle over time. And this image not only has the exterior shape of the vehicle, the overall size, the width, the number of wheels, but also has a view into the vehicle itself, which allows us then to, for example, identify where the driver is in the car, and then where the seats are in the car, and then count how many people are in each seat. Or how many seats are occupied within the vehicle.
Sure. Yeah, maybe we can't discuss the details of how we do it, but the advantage of radar is that we could distinguish between dynamic and static points. And that's something other sensors really can't do by definition. Maybe if they have to do it, they have to use massive computation to be able to do that, but radar doesn't really have to do that. So if you could extract the shape of the vehicle, there's a whole class of other applications that people currently use lidars for, to count the number of axles. Mm-hmm. And that's for like tolling and applications in the highways or otherwise other applications that they might have. Do you think we could use millimeter wave radars to do what essentially optical sensors such as lidars have been traditionally able to do?
Oh yeah, certainly. With the point cloud density and the detection performance of zPRIME, for example, we're able to approach and then sometimes even exceed the performance of lidar in applications like this. And when we piece together and assemble the shape of the vehicle, again, as I mentioned earlier, we know the size of the vehicle, the volume of the vehicle. We also can count how many axles are in the vehicle, which is used everywhere for tolling, whether you're like a passenger vehicle or if you're a pickup truck or if you're like a semi truck, for example, with 5, 6 axles. We can count each and every single axle, and we can use that number to toll accordingly automatically. Or we can determine whether a truck has a trailer attached to a hitch, or if a truck is like a box truck, for example. And being able to classify and distinguish between these cases is very key for automated tolling across the world.
Because the existing systems often use lidars or cameras, but the more advanced systems use lidars, and it's just looking down onto the road or highway. There is a lot of opportunity for these sensors to get occluded by dirt and rain residues or snow or otherwise maybe even fog and stuff. Again, radar wouldn't suffer from such conditions. I wonder how the maintenance would be on these sensors for certain countries that really suffer from maybe snow, rain, and maybe very dusty weather and roads.
Yeah, I mean, this is something that makes a big difference when you're deploying a system, countrywide. When you're at that scale and you have, thousands of toll booths, or you have thousands of, let's say, HOV lane checkpoints, to be able to count and determine what's going on in your lanes automatically without needing to go out and maintain, like clean your lens, wipe it down, or suffer from outages when we have inclement weather or bad lighting conditions, or at night, or let's say the sun shines at a certain angle and blinds your camera. Like these are all things that happen in the real world that radar is fortunately immune to.
That's right. Can you comment on the size and the weight of, let's say, zPULSE for this market?
So this is zPULSE, one of our newest imaging radars. This takes the technology and high performance of zPRIME and distills it down into a smaller package. And
it's lovely. It's so small, man.
This is like the size of a phone.
What's the weight of this?
This is like...
Oh, this is smaller than a phone. I wish I had my phone with me. This is almost half the size of a phone.
I mean, it's roughly the same width as a phone, but it's smaller than my iPhone here. Yeah. And I mean, the sensor is like, it's super lightweight, so you can pretty much mount it anywhere you want.
I think it's like 200 grams.
Something like that, yeah. And it's super rugged. It's IP69K. You can pressure wash this. I mean, and this thing will just take it all. Yeah. And one of the interesting things about zPULSE and really all of our products is that we offer the sensor in many different fields of view. And for zPULSE, we also offer this sensor in multiple frequencies. And a key, as you mentioned earlier, new band that's opening up in Canada, the US, EU, and really worldwide is the 60 gigahertz band, which allows you to deploy radars for stationary surveillance security applications. And zPULSE is our first imaging radar with our software-defined imaging radar technology and performance that uses this frequency.
And this has edge computation capability.
Correct. We have a very flexible software offering that allows us to gain all kinds of insights for many, many, many different markets and applications, all within the radar itself.
Awesome.
It's like an app store of sorts.
For this specific radar, the vertical field of view is
90 degrees.
And then horizontal field of view?
120 degrees minimum.
Minimum.
It goes wider than that.
How many of these sensors can work simultaneously together? Is there a limit on how many of these we could deploy out there?
Really, no, because of the interference protections that we've implemented in the radar. You can put as many radars as you want.
Right. And because this is at the frequency band of 60 gigahertz, there's no way this would interfere with a vehicle radar, because vehicle radars are 76 to 81 gigahertz.
But even our 76 to 81 gig radars wouldn't interfere.
Yeah, but there were some FCC complaints by some companies. I wouldn't name the names. They complained that, often OEMs, that they claim that if traffic monitoring radars are at 76 to 81 gigahertz, there is a possibility that they would interfere with the car radars. But every expert said, oh, this is not true. This is impossible. I mean, it is possible, but it's really impossible because the cars are already interfere with each other. So if they're supposed to fail with interference, then there would be a problem. But the rule in the US is you have to use 60 gigahertz.
Well, thank you, Mazi, for joining us on the show today and talking about some new frontier applications for imaging radar. Every day that we're here, we find more and more new things that we can use our radars for. So,
always a pleasure to talk to you. Thank you.
Thank you as well. Alrighty, well, thank you everyone for joining us on our 4th episode of Clear Signal. If you have any questions about our traffic monitoring or people counting applications, please feel free to reach out.